Welcome to my quick tutorial on how to utilize Ohm's and Watt's law. So let's go ahead and get started with Ohm's law. Ohm's law says that V is equal to I times R, where V is the voltage across the circuit, I is the current through the circuit, and R is the total resistance of the circuit. Because this formula has three variables, we can look at it in two other ways. We can state that the current of the circuit is equal to its voltage divided by its resistance, or its resistance is equal to the voltage across the circuit divided by the total current through the circuit. A convenient way of remembering all three formulas is to put them into a format that's easy to remember. A lot of people like to use a circle. I prefer to use a triangle. When we look at all three formulas, we see that I and R are multiplied together, and V is always divided. So what that allows us to do is put V on the top of the triangle, and then I and R at the bottom. Let's go ahead and use our triangle and practice a few of the Ohm's law problems. Let's go ahead and start with voltage. I have a current of 4.7 milliamps and a resistance of 1 kilo ohm. So how do we use our triangle? What we do is we cover up what we're looking for, and in this case it's V. So if I fill in V, it tells us that my formula for finding V is I times R. So we have V is equal to I times R. So my current is 4.7 milliamps times 1K. So let's go ahead to the calculator. I have 4.7. Now milli is minus 3, so I had exponent plus or minus 3 times 1K. 1K is 1 to the third power, so 1 exponent 3. And that gives us an answer of 4.7. So let's go ahead and do another one. I have a current of 21.5 milliamps, a resistance of 11.2 kilo ohms. So I cover up my voltage, and it tells us it's I times R. So V equals I times R. I is 21.5 milliamps. R is 11.2 K. So 21.5, and again it's milli, so my exponent is negative 3 times R, which is 11.2 K, and K is an exponent of 3. And our answer becomes 240.8 volts. Let's go ahead and look at some current problems. If we have a circuit that has 12 volts and has a total resistance of 3.3 K, what we do is we cover up I, and that gives us I equal to voltage divided by resistance. In this case, we have a voltage of 12 volts, and it's divided by 3.3 K. So we have 12 divided by 3.3, and K is exponent 3. And our answer is 3.636363 milliamps. And we can round that off to 3.636 milliamps. Let's go ahead and do another one. I have a voltage of 5 volts on the circuit and a resistance of only 150 ohms. So I cover up I, and it tells us that I is equal to V divided by R. V is 5 volts, and that's divided by 150 ohms. So we have 5 volts divided by 150. Now because there's no K, I do not hit the exponent. And that gives us a current of 33.333 milliamps. Finally, let's go ahead and find the resistance of the circuit when voltage and current is known. I have a circuit with a voltage of 24.6 volts, a current of 130 milliamps. So we cover R up, and it tells us that R is equal to voltage divided by current. Our voltage in this case is 24.6 volts. Our current is 130 milliamps. So 24.6 divided by 130, and because that's milli, it's exponent -3. And that gives us a resistance of 189.23 ohms. Let's go ahead and look at another circuit. We have voltage of 9 volts, a current of 789 microamps. So again, we cover up R, and R is equal to V divided by I. So my voltage is 9 volts, and my current is only 789 microamps. So we have 9 volts divided by 789. Now micro is an exponent of -6. And we get a resistance of 11.407 k ohms when we round up. Let's go ahead and look at Watt's law. Watt's law states that power is equal to current times the voltage, where V is the voltage across the circuit, I is the current through the circuit, and P is the power consumed by the circuit. Now because we have three variables, we can use algebra to rearrange them to find I equal to the power consumed divided by the voltage across the circuit, and we can find voltage equal to the power of the circuit divided by the current of the circuit. Now we could go ahead and put this in a format that's easy to remember, and I choose a triangle where we can put P in the top part of the triangle and then current and voltage in the bottom. Let's go ahead and do some examples, starting with finding P. We have a current of 12 milliamps, a voltage of 120 volts, and we find P by covering it up, and it tells us that our circuit is equal to P equal to I times V. I is equal to 12 milliamps times 120 volts. So 12, and it's milli, so it's exponent -3 times 120. And that gives us an answer of 1.44 watts. Let's go ahead and do a second one. So I have a current of I of 20 milliamps, a voltage of 5 volts, and we cover up P, so P is equal to I times V. My current is 20 milliamps times 5 volts. So 20 milli, so that's exponent -3 times 5. And that gives me a power of 100 milliwatts. Let's take a look at the circuit when we want to find current. We have a circuit that has a voltage of 120 volts, has a power of 60 watts. So we want to find current, so we cover up I, and that tells us I is equal to P, or power, divided by V, or voltage. In this case we have a power of 60 watts divided by 120 volts. So it's 60 divided by 120. And we get 500 milliamps. Let's go ahead and look at another one. I have a voltage of 12 volts, a power of 10 milliwatts. So we cover up I, and it tells us that I is equal to P divided by V. We have a P of 10 milliwatts, a voltage of 12 volts. So 10, and because it's milli, it's exponent -3, divided by 12. And our answer is 833.33 microamps. Finally, let's use Watt's law to find voltage when we know P and I. My current is 500 milliamps. My power is 22 watts. So we go ahead and cover up V, and it tells us that V is equal to P, or the power, divided by the current through the circuit. P is 22 watts divided by 500 milliamps. So I have 22 divided by 500, and it's milli, so it's exponent -3. And we have an answer of 44 volts. Now let's go ahead and look at another circuit. I have a current of 2.2 milliamps and a power of 4.45 watts. So we go ahead and cover up V. It tells us that V is equal to P divided by I. Our P is 4.45 watts. Our I is 2.22 milliamps. So 4.45 watts divided by 2.22, and of course it's milli, exponent -3. And it gives an answer of 2.005 volts.